Hello, welcome back to another session of the Raytracer Challenge, where I implement a raytracer based on this book, The Raytracer Challenge, by James Buck, in a language, Rust, which I've not used before starting to develop this raytracer together with you. So yeah, welcome back. If you are new to this sessions, there are links in the video description below for you to follow along. There is a link to the code repository, to this book, as well as to some other stuff, just to follow along if you would like to take a look at the code yourself, to compile it, to modify it, yeah, to have some fun with it actually. So please feel free to do so. And yeah, comments are as well always welcome, so please comment on those videos. If you have any questions or remarks or something like this, like some other people did, where we will take a look in a second, because there was a comment regarding an error in my code, which I seem to have missed, and yeah, we will fix it today. But for now, let's first take a look at where we stand. The last time we worked on our raytracer itself, we actually implemented this striping system here. You can see it here in my raytracer REPL, which is a WebAssembly compiled version of our raytracer. We have this native Rust version, and I've created a WebAssembly version from it. You will always have access to the newest version of it if you want to play around with it at raytracer.xyz. So please feel free to interact with this shell. The source code is of course available as well, so if you want to tinker with it, just take a look at GitHub. It is linked up here in the corner. So yeah, the last time we worked on the raytracer, we implemented patterns. So for example, this striped pattern here, which I've applied to, as you can see here, to all of the different objects in this scene. So we have these spheres and this floor here, which is a plane actually, where we applied this stripe pattern with black and white. I could, for example, change this color and we would have yeah, not in this, because I've changed the right sphere, and the right sphere only currently is within one stripe. But let's take a look at for example, the floor here, and if I change this here, we should actually have, yeah, a green-white color and green-white thingy, and now we should have something even worse from the color composition. But as you can see, I can define these colors, and it works actually out. But we have a little problem with the transformations here in general, because as you can see, all of the striping is absolutely identical, like it would be if we had a kind of a filter before our camera. So it is in the perspective of the world. So not of the object, but of the world in the camera perspective. And even though this is kind of a nice effect, we of course want to be able to have these patterns where we are going to most likely implement more of in the future. We want to have them transformed into the space of this object. So for example, we have this sphere here, and this sphere obviously is smaller and therefore transformed in contrast to this bigger one here. So what we want is actually to have, for this sphere, to have a transformed pattern as well, so that it is corresponding to the transformation of the object, of the body we are actually creating, and we want the pattern to be transformed as well, and not being it in world space as it is now. Furthermore, we might want to transform the pattern on its own. So we might want to be able to apply transformations on the pattern. So yeah, we might need to implement this as well. And this is actually what we are going to do today. At least we are going to take a look at it. It's quite some time since I've really worked on this rendering code part of the raytracer. The last session, I've taken a look at another tool to create a bundle of this thingy here. which is Rust related as well. You might have seen the video. And the time before, I've implemented the parsing parts which parse our YAML definition here to enable us or to allow us to define those patterns here in YAML. But actually the last time I really went ahead and implemented a part of this rendering engine here was last year. So yeah, it's kind of a hectic time for me at the moment. So I apologize if I'm not sticking to the weekly schedule at the moment. I hope to be going back to it hopefully soon. But yeah, I'm not sure when I can. At the moment, I'm just doing one of those videos when I have time, and yeah, I have a lot of fun doing those videos, so I miss doing it every week as well. But I hope to be able to go back to it in the future. But for now, I will do it when I have time and will publish it, of course. So yeah, but before we are going to further move along with this transformation stuff, let's have a look at a comment someone left at my YouTube page regarding an error, so that we can fix it. So here we are. This is a comment on the stripes video. So the video where we first implemented this stripe pattern from Joao Vinicius. I'm not sure if I've pronounced it correctly. I've most likely not pronounced it correctly. I'm sorry for that. But thanks for the comment. It's much appreciated. So there is actually a hint that in the color add function we have implemented, we have to guarantee not to have negative values. So that we have an absolute in our function here, because we essentially seem to have a problem that a test either shouldn't parse. We may have created it wrong, or it passed and it shouldn't have. We will see. But so let's take a look at what is happening there with this color add function. So let's jump to the code and let's see. So where did we actually implement this color add thingy? Okay, not here. Let's take a look. We have this pattern. As I've said, it's quite a time since I've taken a look at it as well. So this is the base pattern, I guess. So where is it? Striped. We have somewhere implemented striped here. And does striped have a color add? So we are implementing stencil for striped. Stencil is our trait that we are implementing for each pattern here. And it has obviously a color function. And I guess this is the part where Joao wants to take us a look. So if xfloor absolute, so what we are actually checking here is the x position, and we need to ensure that it is non-negative. So do we need to do this? What test is he referring to? The assert tuple color black toss test would not pass. Yeah, which one of those tests is that actually? The assert equals p color add. We are minus 0.1. That is one that actually tests the minus there. So no, not this one, but let's see. So we are actually but aren't we, I'm thinking, aren't we expecting and doing the right thing? So are our tests cargo run test, or was it cargo tests? I haven't done this for so long that okay, so all our tests are actually passing. So the question is, now, is this test correct? Because Joao in the comment notes that he has a black here. So it should be he thinks this should be black, and I guess maybe he's right, because let's see, a stripe pattern alternates in X, so it should alternate the color, and even around the 0 position it should alternate as well. So let's see. So if it's above 1, it's slightly above 1, it should be black. And if it's slightly below 0, if it's slightly above 0, it should be black, which is here. So maybe we could introduce another test which ensures that, let's see, that at 0.1, and we could actually put this one here, at the positive side, so at 0.1, it should be black. And once it's crossed the threshold into the negative territory, it should be -0. It should be white. And it should be white until it is... So it should... This one actually then should be black already, I guess. So this is a kind of strange... Because this should be the point where it flips again back to black. So it does seem to flip back if we are just over this point of -1, but it should already be at the point 1, because the positive side, it is like this. The problem I see with actually checking here for an absolute value would be that it would be mirrored on the 0 point. So if we are on the negative side, we wouldn't have alternating stripes. We would have the same stripe as we have in the positive region, wouldn't we have? So I guess this is actually right. Let's see. We have this test. We have in the 0, 0, 0, we are black. So from 0 to 1, we are black. And from 1 to 2, we should actually then be white and then black again. So if we're in the negative region, we should be from 0 to -1. We should then be white and then black again. So I guess this is as it should be. I've just added this 0.1 test in the positive to be black. Let's see if this one runs. But I hope and guess it should. Yeah, seems okay. So for me, this actually seems to be correct what we are doing there. So let's take a look again. In the color add function, you have to guarantee not to have negative values. The correct thing would be, why would I have to guarantee this, Zhao? Can you? I would be happy if you could elaborate on this, because at the moment I'm not 100% sure why you think that the implementation is wrong and that at -0.1 the color should be black and not white. Because I would guess that that this is actually what is currently happening is actually what the desired behavior would be. But maybe I'm missing something completely here. So I would be glad if you could give another comment on what's actually why we actually are of the opinion that this is a wrong implementation. Because I'm not 100% sure yet why it would be wrong. So I will leave it at that for now, because I think this is correct. But please, really, much appreciated. Your comment is much appreciated, and please, please comment on it again if you're seeing things different and if I'm missing something here, which I most likely do. So yeah, please just talk to me about that. So, okay. The next thing we wanted to do, let me close this one, is to have this transformation here. So what we currently have is we are applying this somewhere. I'm not even sure where we are calling this actually. So let's check where are we calling this. We are obviously somewhere calling, not in pattern, but most likely in material. Yes. So, let's go to the material, and there is something like color add. So yeah, so there we are calling the color colorette for the material. What I'm thinking right now is we need the transformation matrix somehow of the object we are patterning there, so that we can apply it actually for our calculations. So I'm guessing we somewhere need to put that in. So the lighting function of our material, does it have access somehow to the object itself? I don't think so, but how do we calculate this then? So I guess we are already transforming this position here, maybe? Are we? I'm not 100% sure, so let's see. Where do we call this lighting? It's too long since I worked on this. So yeah, I guess the world, yeah, the world calls it. So let's see. The world calculates ray intersections, and then it takes the gets the material from the hit, checks if something is in shadow, of course, and then calls the lighting function with the calculated hit point, the I vector, the normal vector, and so on. So yeah, and this is enough for us to calculate the lighting actually. So but we need the body information here. Yeah, so I guess let's start at our pattern so that we see what we really need. So we don't only need the position here, but I guess we need the body as well. So this would be a body then. Import, yeah, of course we didn't use it before, so we want a body here. And do we really need a body here, or do we want a reference? A reference to a body is perfectly fine for us, I guess. Patterns aren't allowed in functions without bodies. Patterns not allowed in wait, what? Should have been this. Yeah, we want a reference to a body there, and we have this tuple there, and now we of course need to modify our implementation here. So we want body is a body here, and we are just passing it through. So we are putting it in here, and now of course we need to implement this. Where is it? There it is, of course, and it is missing the body. So let's implement this one here. So we are now getting, oh no, we are getting a reference to a body. So we are implementing this. And now we need to, the question is, how did we actually call those things before? Because I know that we have the differentiation between the method which does this for a specific coordinate and which transforms stuff before for intersections as well. And I guess I would like to name things equally. So let's quickly check where is our sphere. So our sphere actually should implement something like intersectable, I guess. Yeah, and intersectable has something like, yeah, exactly, intersect in object space. So I guess we should, and it then has all of this transformation in here, and yeah, actually calls this transformations then before it passes things on. So so maybe we can do this the same, because I guess we will need it for other patterns as well. So I guess we could have something like a colorette which takes the position and the body and stuff like that. But this one we would implement, wait a second. No, this one doesn't. This one is color at in, let's call it pattern space, because we are we will most likely have first the object transformation, and then we will have its own transformation as well. So let's see. So let's see. And we now have this, this color add function, and we have a new function which is color add in pattern space, and it simply takes a reference to self and a position which is a tuple, and it returns a color. And this color add function here will most likely be identical for all stencils. Yeah, I guess so. So we can actually implement this one. So let's move this. So this is actually now what we want to realize here is the transformation part. Before we pass this position into the color add in pattern space, so that the pattern itself can calculate the pattern information completely without knowing about all this transforming that's going on. It only knows that it gets the right matching things. It is creating a color add in pattern space, and it doesn't care how this pattern space transformation is done. Yeah, that sounds reasonable to me. So let's see. Let's implement this here. I guess in the end we will have something like a pattern space position. So, and this one will then be, we will call self.color_add in pattern space, and we will have a pattern space, come on, position, there we go. And as it is returned, we won't have the semicolon here. Now it doesn't know about the pattern space position, of course. So let's implement this. I'm just realizing I haven't written Rust for a really long time, so that's why I'm really trying to get back into it again, and yeah, it's kind of I need to get back into the mindset and the syntax. So we now have this color add function here, and we want to have this transformation. So what do we need to do in order to reach our pattern space transformation? First of all, we need to transform into object space. We are doing this by object space. We are doing this by object space. Syntax completion in comments is something strange. I need to check if I can configure this in the IDE. So we want to transform into object space. This is quite easy. We have position or object space position, and that will actually be the body dot. It should have a transformation or something like this. It will be the transformation matrix of the body, the inverse of it multiplied with the position. So we are applying the inverse transformation of the body against the position vector, position tuple we have there, and this should actually give us the object space. But where the heck don't we have access to? Don't we have access to this kind of information here? So an intersectable has a material, it has a transform. Yeah, and that's exactly what I want to have there. So a body is an intersectable, is it not? Intersectable for body, yes. So we are actually implementing this, aren't we? There we are implementing transform. What did I do wrong there? Let's see. Pattern. So body.transform. Yeah, so we get the transformation from it, and we get the inverse from it. and we are, why is this not? Expected struct color found, mismatch type expected. No method named transform found for reference body in the current scope. Items from traits can only be, oh, yes, of course. So we need to import intersectable, of course, and then we can actually get this information here. Yes, and then we can multiply this with the position, and then everything should be fine. Yeah. So now we have the coordinate in the position in object space. Let me quickly reformat this, and now we need to put it into pattern space. And for now we. Let's just see how this looks if we don't put this into pattern space already, but only take a look at it in object space, because for pattern space we need to give the pattern a transformation. So let's have this object position here. Let's render. Oh no, no semicolon there because we want to return it. So let's do this. So the naming isn't 100% right yet, but let's see if this works out at all. Not all trait items are implemented. Yes, they are not. This is right. Because I guess I need to implement then color add in pattern space, and it gets a position, all right. And it is dispatching to the corresponding function there. Did we do this the same way for the body? Yeah, I guess yes, but intersect in object space, intersect normal. No, we did not. So how did we get around having to implement this one? Oh, I guess I don't need this one anymore because, yeah, of course, because it's part of the pattern now. Yeah, okay. So the part of the trait now. So, okay. Yes. And this makes absolute sense. So now we are not calling color add anymore, but we are calling color add. No, we are calling. No, this one, of course, all of those calls in our tests now need to be adapted to the in pattern space thingy here. Sure. Or we would need to put a body in there, I guess. Maybe we should put a body in there, which is just a. Should we? I mean, we could create a body here, so let's do let's body, and we create simply a sphere, so why not? Create simply a default sphere here and put it in here. Cannot what? Hello default. Not default. Body. So yeah, we want a reference to a body here. Let's reformat everything. Let's check if the tests are still running. Cargo test. No, they are not. What is wrong there? Pattern color add, yeah, of course, the usage, because now we need to provide the body when we are here in the lighting function. So I guess we will just put it in there. Body. Let's put in a reference to a body here, and we can then put the body reference here. Oh, so do we need to import it, and method lighting and the trait. Yeah, of course we need to modify the trait as well. It's a good thing that we don't have a lot of different materials yet, because otherwise we would need to adapt them, but yeah. So illuminated lighting, yes, we are implementing it for material, but we need to implement or define it for the, oops, what did I do there? For the trait itself. So yeah, let's do this. And now we need, of course, to pass the body through here. And then where are we here? Yeah, we need a body here now, but shouldn't we actually have one? No, we don't have, so let's quickly create one body. Yeah, so now this should maybe hopefully compile again. So now we are a little bit further. So of course now the lighting function in the color add here is a problem, but this isn't a problem at all, because now we need to pass in the body, and we have the body because we know the body as it is part of our hit structure. So let's put a reference to our body in here. And let's see, does this compile now? No, it does not. So what's chapter 6? Okay, we have some incompatibility now here from one of our executables where we are directly using this one here, and we didn't have we didn't have the world here yet. So where is actually, does the hit here should actually have a body? So can I just pass this in here? Yes. So let's see. And our unit tests are all passing again. And now if I cargo run bin, what was it? I guess chapter 09 render YAML something, this one. Render YAML, yes. In release mode, this was the last one we had. And then we could put in a YAML. So we have those worlds here, and we have those. We have 3 spheres and a floor, and we have 3 spheres and a floor with striped patterns. So I needed to, oh no, that's not what I wanted to do, but yeah, let's compile it. No harm done there. So yeah, we need one thingy here, which is the path to, and I guess you will not be able to read it. Let's move this one up here so that you can actually see what I'm typing there. So we need to put in here the YAML file, and now it should, yeah, it's now rendering it. So let's see what's now the result. This actually was the last result that we had. So there the stripes aren't in any way transformed with regards to the objects itself, and now actually the output should have been transformed into object space. So let's see. And yeah, as we can see, it has. So all the different spheres are essentially cut in half, because in object space, all of our spheres are exactly 1 in size. So they have a radius of 1. So if they have a radius of 1, they have a diameter of 2. So they have exactly place for, we are alternating each exactly round number. So we are alternating from 0 to 1 and 1 to 2. So they are exactly cut in half. So this is actually working. It's now transformed into object space, which is quite good because we have achieved the first goal we had there. But we want to obviously be able to transform the pattern itself. So we want to be able to allow for transformation here, that we could, for example, make this this pattern of the middle sphere a little bit smaller, or move it to the left or the right, or rotate it, or something like this. So we want to do that as well. But for now, let's see that we actually, because I'm quite happy with this change, and we changed a lot of different files to do actually achieve this. Let's have a look again, because I guess I want to have this colored in pattern space. Yeah, let's just mark our implementation here. No, that is not where I wanted to go. Let me get rid of the console. Where is it now? There it is. So, and this is not even where I wanted to go. I wanted to actually go here. So let's see. Let me delete this, and let's put a fix me here, and let's do something like have pattern support its own transform, and really transform into pattern space. So let's have this here as a marker, so that we know that we want to get along with it, because I want to commit what I have done here now. So let's see. Let's see what we have here now. We actually introduced this backwards compatibility thing in chapter 6. That is all right. We imported body there in the material. Okay, we passed it through the lighting function. Yes. Pathing through. That is, we now give the color at the body, so we are passing through there as well. There we are adding to the tests. Yes. That is all right. That is, yeah, we are actually there having this transformation integrated, and we have it there. We are passing it through again. So we have this function. This is adaptation of the tests. Okay. This is again passing through, yeah, at the world stage. So let's commit this, I guess. Implement pattern transformation into object space. In order to implement object space transformation of patterns, they needed to patterns. It is required for them to know the object body transform. In order to achieve this, or in order to provide this, to pass this information, we are passing along a reference to the hit body object. Transformation into custom pattern space via custom transform of a specific pattern is marked as a fix me. There we go. So we already have that. That's kind of nice. So let's see what we can do about this pattern space transformation. In order to be able to realize this, we actually first need to give a stencil, or better said a pattern, but the stencil is the trait, so we need to give a stencil the capability of having a transformation. So I guess we are now just doing it as with the bodies, and tell the system that we want to be able to get a transform of a specific stencil, and this transform will be a 4x4 matrix. And yeah, let's see. I guess this needs to be implemented by the yeah, we need to import matrix there. This then needs to be implemented by each of the patterns. So we need to, of course, let's ease this by just copying things. Transform, no, we don't have any input, and we will get a matrix 4. Yeah, most likely it would have been faster if I had implemented it there, and this is so we are just passing it through to the pattern itself. Method transform has a self declaration in the impl, but not in the. Oh, did I not? I did not. Of course I did not, because I've not written Rust in a long time, and I've just forgotten about the self-reference, which needs to be explicitly stated there. So yeah, let's take a look. So now our striped thingy here will get a transform, I guess, which is a matrix 4, and we will have this one, and it will simply have a transform, and we have a matrix identity, I guess, didn't we? I thought I had, yes, I had something like this. So the basic transform is an identity transform, and we will simply create, yeah, let's create a pub fn. Let me scroll a little bit higher here. Pub fn with transform, and we are taking a mutable self here, and we are taking a transform, which is a matrix 4, of course, and we are returning self. And so we do a self.transform equals transform, and we return self again. So now we should be able to, oh no, we need to obviously implement the fn transform, which gets self and returns a matrix 4. And this is simply self-transform. So now our stencils and our stripe pattern can store a transform. And now that we have this, actually, should be essentially quite easy to be able to create this. We should be able to simply do a self dot. So we want now is pattern position. So we want to transform into pattern space here. And this should actually be self dot transform dot, we need the inverse of it, and we multiply this one with the object position. So now we should actually have a pattern position. So as we are already in object space, we can now apply the transformation of the pattern, and then we will have it one step further, and we have the pattern position. No, not a semicolon there. So transform into pattern space. I'm not even 100% sure that these comments are needed, but why not? They are not. They don't make things worse, so why not? So okay, this should actually cargo test. I still need to, of course, add some more tests to check all of this stuff, but for now let's have those. It's still compiling, so this is good. So how would we be going ahead and testing this yet? Yeah, we can actually only test this or easily test this if we allow in our world loader, our YAML parser, to actually parse those this structure. So let's take a look here. So we are somewhere here parsing patterns. Visit pattern. So yeah, there we are, and we are visiting stripe pattern there, and I guess the stripe pattern then should actually read this transformation. So how would we want to define this one? So let's take a look. We have here we currently have this syntax like we define a pattern here, then we have a type, and then we have arbitrary properties. I guess we should do it the same way as we have here with body and there a type, and then we have something like material and transforms, even though we should maybe just have something like transforms here, I guess. So yeah, let's first create this syntax, and then let's make it work for us. So let's have a transforms here, yeah, why not? And then we can have the same structure again, I guess. So we have then a type, let's say scale, yeah, why not? So and then let's do something like 0.1, so it's really narrow striped, yeah, why not? And we do this in every axis. So even though we actually only need to do it in the y-axis there. Oh, I need to, of course, have something like this here then. Why this is, oh, there is a comma missing. So now this should actually be a scale, and maybe let's do a rotation around the, let's think, we have x, we have y, we have z. Let's maybe rotate it around z, so it should be something like this. So let's rotate z. No, there is a type missing there. And then I actually have no idea about the, do I not somewhere rotate something? Okay, I need to take a short peek at how do I rotate. Oh, that was the wrong file. How do I, didn't I have the world loader open? So the YAML loader. So let's see, haven't done this in quite, this is not the document I wanted. So this is the document I wanted, and we should have something like rotate Z here. Okay, so actually we are specifying it by radians. Okay, so let's see. So I am doing, where is it? There it is. So let's have this one then scaled, and then let's have it like radians. So like 45 degrees, which would be a quarter of pi. So yeah, it's a quarter, it's half of pi. It should be half of pi, shouldn't it? Pi. Let's put something like this just in here, and let's see how this works out, and we can change it later on. So just for now, so we want to actually pass this transforms thingy here, which is identical to such a transform here. So we more or less can use the same parsing syntax for it, which is actually quite nice. So let's actually see how we are doing this. So we are somewhere having something like visit transform, I guess, or transforms. Yes, we have. So yeah, if it is containing something like this, so let's simply steal this information here, and let's have there this visit stripe pattern, and if our pattern hash contains a key which is called transforms, then we get our value here, pattern hash. We are getting it, we are pushing it onto our segment stack. We are having something like, okay, I guess we need to have something then here like to make us easy for it. It's just a matrix identity, so we are always setting it, which is easier than optionally setting it. But why actually? We could Don't know, don't care at the moment. Maybe we can do it a little bit nicer, but let transform be a matrix identity. Why is it crying? Yeah, I want this to be because I want to. Okay, so this is the problem type annotation needed for cannot infer the value of const parameter d. Okay, do we? Why not? Okay, it can't be inferred yet. It will be able to infer it. So so now we are visiting this transformations, and we are going back out there, and now we are doing something like with transform here, and we are putting the transformation into it, and now it should be able to infer things, and now it should be needed to be mutable. Yes. So now we should actually be able to pass this. So let's see if we run our rendering from before here again. Let's recompile this. And it has passed the YAML, so it seems our changes work as they should. Let's see, it's ray tracing. And then the moment of truth. Let's see. Open main camera PNG. And yeah, and okay, it should have been a quarter of pi for 55 degrees. For 45 degrees. So, but as you can see, now we can actually transform our stripings here. So let's, yeah. So let's change this and let's correct and do what I actually wanted there. I wanted to rotate it by 45 degrees. So we definitely need to implement something here that we can put in degrees there. Maybe I will quickly do this in a second. Let's see, because it would make things a lot easier. Okay, let's re-render and let's see. So yeah, so so this is actually what I wanted it to be. So yeah, I think it looks kind of nice. So maybe we should do something to those here as well. So maybe one of them I would like to, let's have the left one, I guess. So let's have a transform here, which would be transforms, and let's have one here which had a scale of, why not? Why we could have a translate here, and we could do something like translate it to 0.5 on the X, the others I don't care. So this should actually move the white stripe, no, the black stripe. It should actually have now a slight white stripe on the left, a slight white stripe on the right, and a black stripe, a big black stripe in the middle. Let's check if this is as I think it will be. And maybe, yeah, we could maybe scale it a little. Should we? We could rotate it as well, like rotate Z radians. Let's rotate it by, no idea, just 0.1. Let's see what happens there. So only a really minimal movement there. So and let's have something for the right sphere as well. So let's transforms this one as well. Type scale. Maybe we just make this one really tiny. So let's scale this to 0.001 or 0.01. Let's scale it to 0.01. I'm not even sure if the YAML parser understands this syntax, but we will see in a second. So now let's try and Obviously, the YAML parser seems to understand this syntax, so let's see. Oh no, there is something, there's something which made things, what has happened there? Matrix is not invertible, but inverse was called. Okay, we somehow created an uninvertible matrix. That's interesting. I guess we cannot easily find out at this point where it happened, but I have a guess that it has something to do with this one here. So maybe let's see if this value is. First of all, let's check that it has nothing to do with the parser itself, so that it somehow creates a float which shouldn't have been like it has been then. And for now, yeah, I guess someone told me on Twitter that the renderer seems to have a problem with really small transformation values. Like if you squash something together, a sphere, into a very small amount. I remember now that there is a problem. Maybe this is exactly what we have just ran into. So I will need to have a look at this. But yeah, as you can see now, this stripe has been moved as I've expected it. This striping here has been gotten quite small actually. Looks kind of interesting and nice actually. So yeah, let's see if we can make this smaller or if it's crashing then again. Actually, we can leave those at 1 because we really don't care about all the other axes. So let's see if this is okay. This is working now. So maybe it was the syntax I've used to define it there without the 0 in front. I will check. Yeah, so this is oh holy shit, this is a little bit of moray effect or something like this. This is not good for video encoding. This is not looking good. Actually, this is not even looking good here on the screen. It's having a very strange effect. So yeah, let's maybe not do it like this. Let's do it like this. But yeah, okay, so this seems to work out quite well. So I'm quite happy with that. So let's go ahead and I guess if this works now, which seems to work and looks good, let's commit things, I guess. So open main camera. And it opened up on the wrong monitor. There it is. Yeah, this looks really nice. I like this. This looks really, really nice. So now we have patterns in a way which we can actually use to transform into stuff in the world, and it's not in object in world space anymore, but in pattern space actually. And we even extended our YAML parser here. I like that. So let's take a look at what we did there. So let's. Yeah, we actually added the transformation there. We implemented this one. This is the transformation. We created the builder function for it. We put the, this is the parsing. So we put the parsing in there. We actually changed the YAML file. Let me do this in a separate commit, I guess. So yes. So implement pattern transformation into pattern space, or implement pattern rendering in pattern space. Yes, so patterns, or better said stencils, now have their own transformation matrix. This transformation matrix can be used to transform each applied pattern individually. The YAML world syntax has been extended to allow for transforms to be specified for patterns as well. The syntax is identical to the transforms syntax of body objects. Yeah, I like that. So let's add this one here. I think, yeah, okay, let's override it. It's okay. I was just quickly thinking about letting it be there in the default way and then having another one, but actually we just stopped the last time while implementing patterns. We weren't finished. So update world YAML with transformed to include transformed patterns, striped patterns. Yes. So let's see. We have now the main camera here. Did we store the rendering thingies last time? Yeah, so maybe we should copy those then. Main camera to, let's copy it to renderings, chapter 10, pattern coordinates or coordinate striped main camera. Come on, .png, and we are copying the second camera as well. Second camera, and maybe we should take a look at the second camera rendering here, which is yeah, that actually looks really nice as well. I really like that as well. That is yeah, that is kind of fancy. So okay, so let's quickly add those No, I didn't want. Oh, I can open PNG files in this IDE. Nice, I didn't know that. Let's quickly add this as well, and let's put it together with the last YAML. Yes, and let's push this, and there we go. I guess this will be it for today. Yeah, I think this will be it for today. We have been quite productive. I can quickly, maybe, now that I've pushed it, I could quickly update the our REPL as well. So why not? Should be easy enough. Git checkout main. Let's get the newest things if we have missed something. Okay, so let's do a Rust cargo. Is it update? I guess it's update. It should now download the newest version. There it is, checking out the newest version, and then it should be simply a matter of npm run build. So yes, let's do a run. No, start, I guess. Should open up a browser here. Let's see. So yeah, this is too big, I know. Yes, so let's see. So now we should be able to just paste our YAML file in here, and if this then, no, these are the graphics which I just learned I can open in the editor. Where is our world definition? It's down here somewhere. No, this is the old one, this is the new one. So if I copy this here and I paste this here, and it should actually strange, it does not. Did I maybe have something old in cache there? Oh, okay, it seems that there was something in the cache, because as you can see now this works. Is this actually rendering? Oh, it's rendering a 4K image, so this is why it takes quite some time. So yeah, so now this does obviously work, which is quite nice. So let's quickly release this for all of you to use it. I guess it was release web, was it? No, it was not. npm. Let's see. What did I do there? How was it called? Release website. So run release website. So I guess it will build again. Yeah. Yes, so actually we should already have now a where is this the wrong browser window? Where is my, there it is. So let's reload this. So maybe I need to, yeah, okay, so now it works. It was just a flaky thing in my browser where it simply used the old cached WASM file. So yeah, so now this is online, as you can see, raytracer XYZ, so play with it, have some fun with it, share your creations with it if you want to. Let me have a look if you do some cool other things with it. And I would be very happy if you would join me the next time I'm doing a session about the raytracer again. And yeah, you can, if you want to, please subscribe to the channel and hit the bell. Give me a thumbs up, leave a comment, contact me. I'm always happy to interact with you. So I hope you had as much fun as I did while writing this, and I hope to see you in the next one. So yeah, bye!